Good morning, guys. Thank you for having me. I'm super happy to be here, as this is my first adaptTo conference. And over the last couple of years, I was giving a lot of talks about AEM and delivery in general. And I decided that it's right about time to get all these things together and walk you guys through the whole delivery, how it starts and how it ends and what happens in between. So it's not like a series of tasks. It's not a single task. It's more of a journey than a single event or a series of events. And it starts on your computer. That's the very beginning. And on one hand, it's kind of obvious, right? This is where you start development. But on the second hand, it's a little bit more complicated, as you have to think about things like, OK, maybe you're integrating with external API, and you have to consider the fact that maybe there's a rate limiter in front of that API, and you have to consider that. Or maybe there will be different endpoints on different environments, so you have to provide some sort of configuration. So of course, it ends in production, and any step that happens in between also matters. So let's start with that development phase. Like 4 years ago, we started thinking about what can we do to make local development better. And we defined a couple of principles that we would like to fill in and make sure that that's the right way to go. So the first sort of thing that we would like to address was the fact that people were complaining or actually saying that, hey, it works on my machine. I don't know why it doesn't work on staging, or I don't know why it doesn't work on your computer. It works over here. So I was really fed up with those statements. So we had a principle to make sure that everyone has exactly the same environment. The second thing is that AEM is not like the only thing that you need to take care of. Like AEM is really important. It's in the core of the whole application stack, but it's not the only thing. Like maybe you have some search engine or like Redis instance or anything that you need to integrate with. So you have to have a complete environment on your local machine. And finally, when anything goes wrong, you should be able to start over as quickly as possible. And it should be a matter of minutes, not hours or days, as like Confluence pages with a series of steps how to set up an instance is probably not the right way to go with a setup that's more complex than just AEM. So we decided on Vagrant a couple years ago, and we're still using that for local environments. We build the whole ecosystem around that. So we provide custom Vagrant images, which contains a lot of things. So one of that is, of course, AEM, actually 2 AEM instances, as that's kind of crucial. The really important fact about those instances is that we install a lot of packages on those and make it a part of that image. So for example, if you need the new Oak version or the new service pack or some internal dependency, it's already there. You don't have to bother about things like how to install that. It's already there and ready to use. So things like dispatcher, it's also available for you on your local environment. As it keeps surprising me, like how people tend to ignore that there's a dispatcher in front. Like it works over IP, and when you put a dispatcher in front, maybe there's some traffic filtering rule that prevents like a selector that you rely on. So that's kind of crucial as well. And anything that's related to the project, like things like Solar or Redis, or we use Notex a lot, and you probably haven't heard about that, but that's the templating engine that we use very often, and we also use that for microservices. So pretty much anything that belongs to your technology stack, that's included in your Vagrant image. So how does it look in practice from developer perspective? So first of all, you need to install some prerequisites. That's kind of obvious. You need Vagrant itself. You need VirtualBox, as Vagrant imports those virtual machines into some sort of hypervisor. We decided on VirtualBox because of the fact that we have various operating systems in the team. So we have OS X users, we have Linux users, we have Windows users, and that's probably the only hypervisor that works everywhere. And you need ChefDK. ChefDK is a development kit for Chef. I'll get into details in a few more slides. So first thing, you need to clone the repository. which contains the Vagrant file, which defines what kind of VM it will be, what kind of port forwarding rules you need to apply, how many memory you should assign, and a bunch of other things. You go into that directory, you run rake init, which will install all the plugins that you need. And finally, you need to run rake up, which will import that machine into your local VirtualBox and make it available for you. And if you're wondering what rake is, this is like make for C or Maven for Java, and rake is for Ruby, as chef is written in Ruby. It's not really important for the sake of that example, but just to give you an overview of what it is. So if it's all up and running, then you end up with a state like this. So you have AEM author that works on 4502, and it's available on localhost. Same goes for publish. You have a dedicated dispatcher instance with a set of domains that are automatically added to your etc hosts file. You don't have to bother about that at all. You have your Solr instance and anything that's needed for local development. We also provide a couple of handy features, like, for example, there's a new hotfix or there's an update to dispatcher configuration. You don't have to rebuild the whole image. You can just apply incrementally an update, and you can use rake again for that. So, for example, there's a new service pack that's required, and all you have to do is run rake provision publish, and it will install that hotfix on your publish instance. And the same goes for dispatcher. If there's an update, you just run rake provision HTTPD, and you're done. We store dispatcher configuration in Git, so it's a matter of like pulling that down and applying some minor tweaks to make it work. And if you'd like to hear more about that, I gave a talk specifically on Vagrant, how we build that, how we make sure that the whole solution works, why we decided on rake, and so on. So if you're interested, there's a separate talk that I gave last year just about that. All right, so we have a local environment covered. Let's move on to continuous integration. So as we all know, we work in teams, right? So there's multiple people working on different features, and in some point in time, you need to integrate those into a single branch. So I have a feature A, my colleague has a feature B, and at some point in time, you need to integrate those in a single branch to make sure that those two features work together. So it's all about code integration. When those features are in a single branch, you need to test that, and if it's all green, you need to release that. And that brings us to the Git flow. Like, people literally spend hours, like days, discussing what kind of Git flow should we apply. Do we need release branches or not? Do we need 2 primary branches or just 1? How many pull requests should we raise? And people used to argue about that for days. But the truth is that it often ends like this. So my suggestion would be just pick the simple one and try to solve all the edge cases as they go. Don't try to fix the world at the very beginning, as it's probably not going to happen. You'll encounter situations that you haven't ever thought about. All right, so let's take a look at a real-life example. So this was the recent project that I was involved in. We had quite a lot of repositories, and that's over like 20 repositories in total, maybe over 30 even. So there's a lot of repositories. And as you may notice, there was like 4 application repositories. And if you're wondering why, I'll get into details in a second. So the core thing about those repositories is that each repository has its own lifecycle. When you release your Apache configuration, there's probably there's no need to release like your Solr configuration, as there's no direct relation between those two. So each repository is completely standalone and lives its own life. And we also have a simple Git flow, so 1 primary branch and a set of feature branches. So it's super simple. We don't want to overcomplicate things. So let's take a look at an example of one of those application repositories. So let's say that we have a feature that's all about product indexing. So we have some content on AEM, and we need to index that content in an external search engine. So that was the use case. So here's a top-level view of one of those repositories. So we decided to bundle the whole thing into a single repository. So of course, there's an AEM part, which is responsible for event handling. Like whenever you put a new product on AEM, there should be a handler that takes care of that event and index that in external search engine. The second thing is a domain, which is internal dependency. That's not really important for the sake of that example, but I decided to put it in just to make sure that the example is complete. We also have a few microservices, and each microservice has its own role. So for example, autocomplete is for autocompletion, indexing is for indexing, and those microservices, they sit between AEM and our external search engine, which was Solr in this case. So we have Solr. That's all about course, schema, or stop words, things like that. And of course, the POM XML. So we have like 3 different parts here: AEM part, microservice part, and Solr part. So what are the benefits of such approach? So first of all, we treated the whole feature as a whole, even though it's distributed among different services. This is the single feature. So whenever we make a change, even in a single place, like maybe we decided to rewrite one of those microservices to, I don't know, be more performant, we have to release all those things. Because of such approach, we don't have to bother about what version of AEM part works with what version of Solr and what version of those microservices have to be deployed to make the whole solution work. It's always the same version across multiple places, and we know that if it's the same version, it should work as we test the whole thing as a whole, as a single unit, basically. So we have one release with multiple artifacts. And that means that we can treat a single repository as a single feature, basically. So now let's talk about how we actually deploy things and how the whole CI works. So we decided to go for pipeline solution, which are extremely popular all these days, and there's multiple choices available on the market. You have Jenkins, which is probably the most popular. You have GoCD, you have Bamboo, and probably a gazillion of other tools like Circle CI or Travis or whatever. And those products allow you to, in some form, define a pipeline as a code. In this particular project, we decided on Jenkins. So we have a Jenkins file, which is a Groovy-like DSL that defines all the stages in the whole pipeline. So here's an example. So we have a pretty straightforward file with 3 different stages. We have checkout, build, and test. In the checkout phase, we clone 2 Git repos. In the build part, we delegate the whole work to a dedicated node over here. So we have a dedicated machine that's responsible for building AEM, so we can delegate that work to a separate machine. We run Maven here, and to run those tests, we execute Gradle. So here's a screenshot of the actual pipeline. There's a lot of things going on. I'll walk you through, guys, in a few seconds what's going on. But this is an example of a pipeline that builds, deploys, and tests a single or a set of applications, actually. So the first thing that happens is you have an input that you need to fill in. And that input is, the reason we have that is we have 4 application repositories. So if you make changes to one of them, there's no point to deploy all 3 applications, all 4 applications, just deploy that single one. You can also pick up the branch you'd like to use as a source, so that's also possible. And here's what happens. So the first thing is we need to prepare a set of Docker containers, as we use that for deployments or for building. And it's like, the step basically says spin them up if they are not already running. We have a quality gate defined in SonarQube. So if your code doesn't meet certain criteria, the build will fail. The next phase is the checkout. So we check, we clone a bunch of repositories. Then we clean up some leftovers that we may have from previous builds, and then we do a build in parallel. So if we decided to build like 4 applications or 3 applications, there will be 3 parallel steps here. Once we have that, we have a series of artifacts like zip files or jar files or maybe some configuration files that were generated as a part of that build, and we need to distribute that across those Docker containers, as we will be using those to deploy those artifacts. So this is what that step is all about. And finally, there's the deployment. We have 3 different AEM instances on that environment, and we have 3 packages here. So over here, there's a first package, second package, and the third package, and those are individual AEM instances. Next is the step related to some post-deployment steps, like we have some internal caches in AEM that we need to flush after the deployment to make sure there's no leftovers from previous versions. We do the deployment of the NOTX and Solar configuration nearly at the very end. We clear dispatcher cache, and we trigger a bunch of tests. So as you can see, there's a lot of going on. And at some point in time, we decided that it's the good time slot for making some improvements, as those pipelines were getting really complicated, and there was a lot of code duplication there. So we decided that, okay, we're duplicating a lot of code, it's getting really complicated and hard to read, so let's introduce something that actually makes them better. So the first step is we need to make the whole pipeline dynamic, in a sense that, all right, we have like 4 applications, we build just one, so we don't need like those steps related to those 3 remaining ones. So let's make sure that we can dynamically define those stages. So it's basically driven by the input from the user on that dialog that you see in a couple slides ago. The second thing is that we had a lot of variables, like what kind of Maven profiles should be used, or what should be notification email, what's the link to repository. So we decided to introduce a couple of configuration files, which were YAML files, and we had 2 stages. The first was local, which is linked to a single pipeline, and we also had one global, which was for all the pipelines. So we wrote a custom shared library, which is a Groovy library that allows you to extract the common logic and distribute that among different pipelines. So here's an example. So we have a placeholder for a pipeline. We need to import that library first to make use of those features that we extracted. So first thing is that we use Maven, the same Maven version, across different stages. So let's define that in one place and make sure that we always reference exactly the same version of Maven. We have a couple of stages here. I removed a lot of code to make it readable. So for example, the SonarQube stage, there's a function that actually calls Sonar API. It actually builds the project, uploads the code to SonarQube, and validates the results. So if we have more than 10 warnings and 2 criticals, then the build fails. And things like execution of common things related to chef, for example, that knife exec is for chef execution. And as there's a common pattern there, so we decided to extract that to a dedicated function as well. Here's an example of one of those configurations. So as I said, this is a simple YAML file. Nothing really fancy, just a few strings that we can refer to and have a common place for them. All right, so what about testing? We use quite a lot of things for testing. So the obvious thing is unit tests. That unit tests, those are present in every single project. We use Bobcat, which is based on Selenium, so we run some tests in the browser. We use a tool called Selenium, which is actually the platform that we run those Bobcat tests on, and it runs Docker containers under the hood. And finally, we use AETs, which is an in-house product of us that we use for visual comparison of pages. All right, so we have a code that passed through some continuous integration. We have a stage related to testing. It's right about time to release something. And people often are confused about what's a release, what's a deployment. And release doesn't equal deployment. It doesn't work this way, at least for us. So you can have multiple releases over the day, but you don't have to deploy them immediately. There's no reason to do so. But the point of release is to put away a stable version of code. So if you merged a branch, tests are passing, just create a version and upload that to some artifact store. So we were like, over the last couple of years, like I've seen situations where people were fighting with release for like hours or even days to make it stable. So we invested a lot of time to make that process as simple as possible and making sure that you're not really paying attention to releases as it happens automatically. So when the release is ready, you have to upload that to a central place like Nexus or Artifactory or some other solution, I don't know, an AWS S3 bucket, whatever, something that's persistent and you can refer to later on. It's really important for the sake of deployments. When we get to the chef part, it will become more clear. So let's talk about the infrastructure. So we have a release. It's right about time to deploy that release on the actual environment. And when it comes to infrastructure, we use Terraform. Terraform is a tool from the same company as Vagrant. And Terraform is all about declarative approach to infrastructure. Since we use a lot of cloud-based environments, it fits really nicely, as it talks over API to like AWS API, and it will spin up some machines for you. It will apply some security groups. You can attach some networks, and it's all expressed as code. So as I said, we have multiple AWS environments, and those environments are identical when it comes to like logical diagram. Like if we have Solr, it's present everywhere. But for example, on production, we have more instances of Solr or maybe more powerful machines. So to address that, we created some Terraform modules. So you can define all the stages that are required to provision like a single server or a set of servers. But it's configurable in a sense that you can provide some input. So for example, on production, you can increase the machine specs, or you can make more of those if needed. And Terraform is also responsible for initial bootstrapping. So whenever we create a new machine, it's also connected to Chef by default. So Terraform takes care of that as well. So whenever we spin up a new server, and it should be a published server, when the whole provisioning process is done, there is a published server up and running as Terraform run the first Chef run on that particular machine. When we have the whole infrastructure, we have to interconnect those machines somehow. And it's getting really hard to manage all of those IP addresses, as there's plenty of boxes. Like sometimes a single environment is like 30 boxes. So how to make sure that we connect to the right thing on production and on staging and any other environment that's involved. So we try to find a solution that doesn't force us to think about hard IP addresses and hard coding them in a configuration somewhere. And we were also looking for something that can adapt to changes by itself. So when I add like a second or third Solr instance, there should be no configuration changes required to make the whole solution work. We decided on Consul, which is yet another HashiCorp tool, And if you're interested how it works and what are the details, I also have a separate set of slides just about that. But to keep things short, we have 3 main features that we use, and that's DNS-based service discovery. So we basically register a service that's available for us over DNS. We use load balancing based on DNS as well. And we also configure some health checks to make sure that one instance, let's say that one instance goes down, there should be no reason to point any traffic to that instance, and it should be automatically deregistered from that service discovery tool. And as I said, there's a separate talk just about that, which should help you understand how we integrated that tool with AEM and what we did to make it work. All right, so let's jump right into automated deployments, as that's the really important part here. And probably some of you know that we use Chef. Chef is a generic configuration management tool. It's not like tailored to AEM or anything else. It's really generic. And it's similar to things like Ansible that's been mentioned yesterday, or Puppet, or anything that sits in the same sort of area. So the approach we have in Chef is, in Chef there's a concept of a cookbook, which is a configuration unit dedicated to a single service. So for example, we have a cookbook that's responsible for AEM deployment. There's a cookbook for dispatcher deployment. There's one for Solar, for console itself. So there's a lot of cookbooks, basically. And all the way Chef works is, it wasn't really approachable at the very beginning, as there was a lot of missing pieces, especially documentation. But at some point in time, like the Chef community decided that there's no point to think about individual things. Let's provide a sort of an abstraction on top of Ruby, so you don't have to think about like how to deploy AEM package. All you need to do is work in a, let's say, declarative approach, which and all you have to do is to define what would you like to do, not how to do it. Let me give you an example. So let's say that there are 3 deployment steps that you need to do. The first is to install a package. The second is to restart AEM after the package installation is done. And finally, you need to remove some Flash agent as you don't need it, or you have some custom one that does some extra thing. So here's an example. And this is the Chef code that we wrote, and this is an abstraction on top of AEM, so you can define all those stages as a plain DSL. It's not even Ruby, it's actually some sort of DSL. So right here, we have a declaration of a CQ package. This is a resource in Chef naming convention. And it has a name, so this is like a variable declaration. So we have a string type variable, which is called foo. And this is the same sort of pattern here. So to deploy a package, you need to provide some details. So on what kind of instance you'd like to deploy that. So you need to provide some username, password, and a URL to your instance. And because of the fact that Chef runs on local machine, it's typically localhost. Okay, so you have the destination. You need to define some source as well. So this is why that artifact store is really important. So whenever you release a package, it's available over HTTP in this case, but you can use like FTP or whatever. It doesn't really matter. And for example, if that's not publicly available, if that's not internal, you can also provide some authentication details here as well. So we have a set of properties for a single package, and the last step is the action. Since we'd like to deploy that, you have to put action deploy, and that's it. So this is a super simple example of a CQ package. In practice, it looks more like this. So we don't have like hard-coded values for those ports or passwords or URLs. It's dynamically generated on some input. Those values here are called attributes. So we have a set of attributes that we can refer to in multiple places. But let's get back to that simple example. So right here, we have a package that will be installed. And the second task was to restart AEM after installation. So all we need to do is to define a second resource, which is service. We have a service that you can use for starting, stopping, restarting AEM. It's called CQ62author, for example. And like, if your initial thought was to put a restart here, that's not actually the case, as if you put a restart here, the AEM instance will be restarted unconditionally with every deployment, which doesn't make sense at all. So instead of that, we would like to make it more like event-driven system. So instead of hard coding a restart here, we can send a notification to that service. So whenever that package gets installed, let's restart that. Let's send a notification to that particular service to restart AEM. All right, so 2 points covered. The third deployment step I was talking about is removing of a default Flash agent. So to do that, we have yet another resource. It's called CQJCR, and it also has a name. And agent is nothing more than a node in your repository. So all you have to do is to just remove it. You don't have to like open any browser to do that. There's an API you can use to get rid of that particular element. So again, some sort of properties. We have a path property, which actually is the path in repository. We have some details about the instance, and we have an action which is delete, and it will delete that particular node if it exists. If it doesn't exist, then nothing will happen. So Chef, one of the principles in Chef is to make the flow idempotent. So when you apply, let's say we have those 3 resources, and during the first execution, that package will be installed, AEM will be restarted, and that node will be deleted from the repository. So right here, we will have like 3 out of something resources were updated. But when we do that one more time, right after that deployment, it should say 0, as it's all in place, there's nothing to do, the package is already there, AEM was restarted before, and that node doesn't exist. So it should say, you can run that multiple times, and it always should say that 0 resources were updated. Here's a couple of examples from like a real cookbook for AEM. So for example, we need to install 70 packages on authoring instance, and there's like 20 modification of nodes in a repository. And if you're wondering why we have 70 packages to install, well, there's a lot of hotfixes. There's a lot of, the whole application is a series of packages. We have to install some service pack. Service pack has a set of dependencies. So there's a lot of packages. And eventually, it's over 70 packages. So this is why it's so important that we have a pre-built images with all those packages, as it would be impossible for anyone to follow exactly the same order of installation every single time you need to set up an instance on your local machine. OK, so what's currently available? Those are the features that are available today. We have a CQ package, a bunch of stuff related to OSGI. Where you can manage users, you can manage repository nodes, which includes agents as well. So you can configure replication agent, for example, or Flash agent this way. If you'd like to execute some Groovy script or APM script, and some of you are probably familiar with APM, as a colleague of mine presented that last year here. So there's a lot of stuff here, and all that CQ stuff is available publicly. It's open source. You can go to that URL to see what's available, and feel free to use it. All right, so that was the Chef part. Let's move on to the last part of the flow, which is orchestration and how we actually trigger deployments on the actual environment. So again, we use pipelines for that. We had a pipeline for building and testing. We have a pipeline for deployment as well. And it's all driven by knife SSH, which belongs to ChefDK, so that development kit. And this is why one of the reasons why you have to have it is that particular feature. So let me give you an example. So here's a fairly straightforward architecture. We have load balancer in front with 2 dispatcher servers behind and 2 publish servers right after that, and a single authoring instance over here. One remark, we have a dedicated dispatcher here just for authoring purposes. So the first thing we need to do is to put a maintenance page on authoring to stop content editing, so there's no changes when deployment happens to content or configuration. And to do that, we need to run a knife SSH, as I said before, and it takes 2 parameters. The first parameter is the query, which is on what servers you'd like to run something, and that something is actually the second parameter. And right here, we are touching or creating a single file on authoring instance, and there's a logic in Apache that detects that file, and if that file is present, then it means that all the traffic, all the authoring traffic should be stopped, and there's a generic static page, like there's a maintenance, please check out that page in like 15 minutes. So you no longer can see authoring at all, at least from the content team, as it's only accessible over the domain. So we transitioned to such state. So we have a maintenance page on authoring, and it's not available for the content team. The second step here is we would like to deploy stuff on some of those nodes. And typically, we split the whole infrastructure into zones. So for example, here's the first zone, here's the second zone, and we'd like to do a deployment over here. So what do we need to do? So knife SSH again, a slightly different filtering here. So we are looking for a dispatcher server in the first zone. And we also touching a file here, but it's not maintenance log, it's deployment log. There's a difference between those two. When we put a deployment log file, it starts responding to those health checks. It actually changes the response. So previously, it was proxied through dispatcher up to publish, and there was a dedicated servlet for that on AEM instance. And if application is all right, then return 200. And if something is wrong, then return something that's not 200, like 503 or something. So right now, we created a file over here. And that means that load balancer will keep sending traffic here. But after like 15 to 20 seconds, depending on your configuration, it will disconnect that, as that file, presence of that file means that dispatcher will start responding to that bin health check. It will start responding 503 to that. So we are instructing load balancer to disconnect that particular path or that particular zone. When it's done, we need to run chef client on those machines in the first zone. So we need to run knife SSH one more time. And right now, we're looking for dispatcher servers in the first zone and publish servers in the first zone as well. And all we need to do is to run chef client. It will download all the required stuff, and it will install that on those 2 machines. So we will end up with, there's one more step, actually. So when the deployment is done, we need to remove that deployment log file to connect that dispatcher back to load balancer, actually the whole path here. So we remove that file, and after like 15 to 20 seconds again, there's a delay because of load balancer configuration. That node will be connected again. So the next step is we need to repeat exactly the same step for the second zone. So one more knife SSH execution. When it's done, we connect it back. And finally, we do a deployment on authoring. So we remove the maintenance page from author at the very end of the whole process. So the application is upgraded on the entire environment. OK, so what we've learned during that process, which is AKA what went wrong and where we failed. So the first thing is that we didn't consider that, at least initially, that you have to fail fast. So whenever something breaks, you should stop the pipeline. Don't make it run further, as if, for example, something went wrong on that first zone, you're connecting not working application to the load balancer again, and it will be a mess. So stop the pipeline if anything went wrong. That brings us to a slightly related thing, is that, for example, that knife SSH doesn't return or doesn't actually passes on the exit code from the command that you run on the server. So when that chef client exits with 1, but the SSH command was successful, it will still says, OK, I'm fine. I executed what you wanted. Even though that failed, that's not a big deal. But thankfully, there's a flag you can use to pass on those exit codes. So when the chef client fails, the knife fails as well, so you can stop the pipeline. And the last bit here is how to resume a pipeline if anything goes wrong. Like, it went half through the whole process and something breaks there. So how to resume the pipeline since given stage, from given stage. And the answer is really simple. There's no such feature. There's an open Jira in Jenkins that basically describes that problem. You can't resume the pipeline. It's a feature in the enterprise version, if I remember correctly. But we found a workaround for that, and that was that dynamic definition of stages. So if you're like one of those applications built of one of those applications failed, you can deselect the remaining ones, just select that one, and it will skip the previous steps. So you can actually, eventually you can pick from what step you'd like to start the pipeline again. All right, that would be it. Thank you so much.
Thank you, Jacob. Any questions? There's one over there. Nothing. Okay.
Yes, I had two tightly coupled questions. One is, where is the artifact metadata, sort of what Chef needs to know, to bring a node in policy for the packages? Where is that stored? Is that in files or in Git?
It actually, we extract that out of the package. So there's a properties.xml file in the package itself. So we extract that, we get the data out of that, so we can compare what's in the package and what's on the instance. And based on that information, we can determine if we would like to deploy that or not, if it's already there, or maybe it's just uploaded, maybe we need to install that. So there's no need to define anything extra. It all sits in the package itself.
OK, but if you spin up an extra node, say, where does Chef then have the most recent
All right, so there's a concept of environments in Chef. There's a central server in the Chef ecosystem called Chef Server, which is a sort of a artifact store and a search engine. For example, that knife SSH command actually sends a request to a Chef server to filter the nodes according to your query. And there's also a second element there, which is an environment. And on that environment, which is effectively a JSON file, by the way, we define like, that's the most recent version. Please install that.
OK.
Thank you. Any other questions? Nothing?
And there's one over there.
I've seen you.
I have a question. How much tests do you have, and how long are they running?
So the most time-consuming part here is the part related to visual comparison, so that AET. Like, the unit tests are fairly simple. The Bobcat stuff, so that Selenium tests, are also quite fast as we spin additional containers if needed. So we can scale it out if we need to run like 50 tests at the same time. So probably the The visual comparison tool, that's the most time-consuming part, and it varies by use case, but I would say that you need at least a couple of minutes, up to like, I don't know, 15 minutes to run the whole test suite.
That's okay.
Hi, I have a question.
Sorry. Oh.
You are using SonarQube in your pipeline? Yes.
Correct.
And my question is, in my experience, you can't use SonarQube out of the box for an AEM context. You have to define your own rules. So how much effort did you spend to define your own rules that SonarQube makes sense in your AEM context?
Let me show you something. All right. Cube. I'm not connected to the Wi-Fi, but we have a set of rules that are also available on our GitHub. So you don't have to like reinvent the wheel. It's already available. We have a few AEM-specific rules, actually more than a few. So we have a sort of an internal company policy for AEM code specifically.
Thank you. Any other questions?
Yeah. Hey, I'm interested for the local development setup thing. I have two questions. Are you using the development laptop as a node, or do you use Chef Zero?
Correct. We use Chef Zero for local environments. We are not connecting those to the actual Chef server.
Okay. And the computers, is it all MacBooks, or do you have?
Unfortunately not, which gets things complicated. So as I said, we have Windows machines, we have MacBooks, we have some Linux users as well. So there's a few challenges around those, as for example, there are some Vagrant-specific issues related to particular OS type. So some version works correctly on OS X, but it doesn't work correctly on Windows, for example. So we have to always validate a new version across all those systems before we decide on upgrade.
And do you share your Vagrant setups, or?
Those are internal and project-specific. So there's a dedicated Vagrant box for every single project that we have.
Okay, thank you.
Okay. There's one question in front. Masood?
There's
one.
Hello. I'm interested in the SonarQube as well, in the SonarQube solution. How do you automate the way that if errors occur in the SonarQube, somebody gets notified to actually fix that? Yeah. How is that automated?
So there are two ways you can automate that. So SonarQube, the team behind SonarQube, they're actually, at some point in time, they stopped recommending that approach, but I'm pretty sure that it's still valid. There's a plugin called Build Breaker, which actually you can configure that that's the maximum amount of warning, that's a maximum amount of criticals, and if it passes the threshold, then break the build. So that's the first way. But as far as I know, it's no longer supported in the most recent version of SonarQube. We have a custom script that calls the SonarQube API, gets the JSON, parses that, extracts the actual data, and compares to the policy that we defined.
Okay. And we'll take the last question over there. And if you've got more questions, I'll ask to get to the...
Just wanted to, in your build pipeline, you're obviously spinning up Docker instances to do the sort of automated testing. How do you then handle manual QA? Is that separate instances that get deployed to, or is that done on the same system?
So when it comes to like a local branch-specific tests, that's a manual process. So it's a responsibility of a QA engineer to build a branch locally, to test that on the Vagrant instance. Those Docker containers are only for like a global tests, in a sense that when we merge a new feature, it detects like regression or any kind of issue that may occur after multiple features get merged.
Okay. Thank you,
All right,
Jakub.
thank you, guys.